Hello everyone, my name is Andres and welcome to part 16 of Senior Developer in 24 Hours. Today we're going to be talking about a really hot topic, which is generative AI and how that relates to our role as software developers. All right, so what is the main takeaway of this video? After this video, we're going to hopefully understand at least the basics of GenAI and how this technology can help us write code, maintain code, etc. More importantly, we're going to learn about some of the limitations and concerns that we have to keep in mind when we are making a decision of, hey, should we use the technology? Where should we use it? How should we use it? At the end of the day, what we're trying to do is we're trying to make better informed decisions about how to use this tool that is changing the landscape of many, many occupations. I do want to preface this with the fact that what I'm going to be talking about is 100% my personal opinion, so take everything I say with a grain of salt. With that said, let's get started. So what is GenAI? GenAI basically stands for Generative Artificial Intelligence, and it is a class of AI algorithms and models that are designed to generate new data or content. So basically, the models will take some input and then they will generate new data, new content for us. Let's talk briefly about the history of the developments that made GenAI possible. One of the first milestones was the Transformer Revolution. This happened in 2017, where a research paper called Attention is All You Need introduced the new transformer architecture, which made the development of future models possible. Basically, transformers allow models to handle long-range dependencies in language far more effectively than previous approaches. With this new technique, what we have is a rise in a technique called pre-training, which allows our models to be trained with massive amounts of data, in particular, massive amounts of text datasets. In 2020, and getting closer to the current times, what we've seen is a massive scaling in the size of these models. A lot of the research was centered about being able to dramatically increase the size of the model. And this is mainly done through the number of parameters. This is a term that you might have heard. Hey, this model has this many parameters, and we're talking about billions of parameters. And also the amount of training data that allows us to train these huge models. During this time frame, we saw the emergence of gigantic models like GPT-3 that exhibited remarkably human-like text generation capabilities and what seemed like a much broader understanding of the world. In 2021, what we saw was the emergence of multimodal models. For example, models that will not only generate text, but will also generate images. They would also be able to generate animations, sounds, music, things like that. So we have tools like DALL-E, things like that, that broaden the capabilities of GenAI models. All right, how does GenAI work? And I'm not going to claim that I'm an expert in the field. I barely understand some of these terms, but it's still important to have at least a basic understanding of what we are talking about and how it works underneath the covers. One of the main things is that GenAI models are built, as I mentioned before, with very large-scale training. They consume massive amounts of data. We're talking about millions, maybe even billions of text articles, images, code samples, things like that. With all of this data, the models will, through machine learning algorithms, uh, the model will learn to identify complex patterns and find the statistical relationships within the data. Basically, it finds the relationship between sentences or words or images, things like that. Once the models have been trained, they can generate new content. Basically, when we give it a prompt, the model is going to use the patterns that it has learned to produce new content. The way the content is generated, it's basically using a statistical model to create a piece of data, piece of text that aligns with the prompt. And sometimes, the model will do it in a surprisingly well way, in a surprisingly well fashion. All right. So now let's talk about how we can use GenAI to actually write code. Because, as software developers, specifically senior software developers, we spend a significant amount of time writing code. And if there's a tool that can help us, hey, why not give it a shot? So you can use different GenAI tools to write code, but generally you want to try to use a specialized code generation tool. Something like ChatGPT, it's a general purpose tool. However, there are tools that are specifically designed for writing code. ChatGPT will, it will help you generate some code, but it can also help you generate a letter, a poem, a lot of other different things, as opposed to a more specialized tool that is dedicated to generating code. And here we're talking about tools like GitHub Copilot, Amazon Code Whisperer, Google Duet AI for developers. Those are tools that are designed specifically to help us write code. And one of the main advantages is that they have good integration with our IDEs through plugins. So right within the IDE, you're able to get suggestions, you're able to get basically all of the functionality provided by the underlying model without having to go to a separate website, pasting up some of your code, doing things, out of band. So right now, it's relatively simple. You sign up for one of these services, you install a plugin, or maybe the plugin is already installed in your IDE, you can start using it. Now, currently most models only work with the data that they have been trained originally. In the future, most likely, large organizations are going to be able to train their own models using their own code base to get suggestions that are a lot more relevant to what they're doing and the patterns that they're using and the styles that they're using and things like that. But for now, most of the models just rely on the existing data that have been previously trained by the companies that provide these tools. All right, so what are some of the advantages of using a tool like this? Obviously, the main advantage is speed and efficiency. GenAI models can automate the creation of boilerplate code, create standard functions. Some of these models can even suggest some optimizations. So by using a tool to take care of the more boilerplate stuff, it allows the developers to focus on the more complex problem solving, more creative aspects of the development cycle. It can also help you reduce errors. GenAI, again, it has analyzed vast amounts of code. So with that, they're also able to identify some of the most common errors that we might make when we're writing code manually. It can also improve accessibility because it can lower the barrier of entry for people that are less experienced to be able to write code. because now instead of writing whatever programming language we're writing, we can create prompts using natural language and then have the tool generate the actual code that we'll be able to execute. Uh, it can also help us to optimize our code. Again, these models can take our existing code as input and suggest ways to improve efficiency, readability, maintainability, all of those non-functional requirements that, sure, we have to keep in the back of our mind, but a GenAI tool can help us constantly improve on those areas. Faster prototyping, these tools can help us write something quick with a lot less effort. This allows us to, for example, experiment, get faster feedback, and improve the overall lifecycle. All right, now let's talk about AlphaGo, which is one of the most significant pieces of AI technology in the recent past. It was developed by Google DeepMind. It was unveiled in 2015. It is an artificial intelligence tool that is designed to play the game of Go. Here we're talking about the board game. We're not talking about the programming language. And this was the first programming. It was the first program to defeat a world-class Go player, which was quite the accomplishment. One of the problems is that, contrary to chess, Go is a much more complicated game. It has a vast number of potential board positions, again, far more than chess. So, this sheer complexity meant that traditional programming approaches didn't work as well for creating a strong Go playing computer program. So again, this tool became famous for defeating a world-class Go player, Lee Sedol, in 2016. Now, some of you might not be familiar with Go, but it is a Chinese board game that was created over 2,500 years ago. So, it has a very long history. It is played on a board that is 19 by 19 spaces, which is, again, significantly bigger than chess. And the goal of the game is surrounding more territory of the board than your opponent. And the game ends after 2 consecutive passes. And this becomes a little bit more important as we go through this conversation, but keep that in mind. All right, now let's talk about another tool. This is another Go playing program. It was released in 2019, so 4 years after AlphaGo. It was based on AlphaGo with many refinements. And it was considered to be a much better tool than AlphaGo. It was supposed to be a much stronger Go playing program. However, CataGo was defeated by an amateur. It was a top ranking amateur, but an amateur nonetheless, in 2023. So the technique that this person, whose name was Kelling Felrine, hopefully I'm pronouncing his name right, he basically used a technique that was devised by another AI tool, and this tool was designed to investigate weaknesses within the algorithm that CataGo was using. And the technique that he used was somewhat complicated, but not terribly complicated. And basically, it was building a large ring of stones, trying to encircle the pieces that CataGo was placing. But it made some moves, outside of the main areas where there was action going on to distract the AI. What this caused was CataGo to basically get distracted from what the player was doing. And then, when the time was right, the Pellerin passed, And it tricked CataGo to also pass, which, as I mentioned before, 2 passes caused the game to end. But it caused CataGo to pass at a point where it was actually losing. So what became evident was that CataGo didn't really know the rules of Go. It was an algorithm that was great at playing against very seasoned players. It was great at coming up with uh, moves that were effective against, again, players that were playing rationally, and they were trying to use very advanced moves. But it failed to understand the basics of the game. It failed to understand the basics of the scoring of the game. So it was fairly easy for this amateur, again, highly ranked amateur, to trick the algorithm into doing something that made no sense. It was able to trick the game. It was able to trick the program to end the game at a point where it was losing. Therefore, coming out with a mechanism in which it could defeat it with very high accuracy. Obviously, all of these weaknesses, they are going to be found. We're going to improve those systems, but it's important to understand that these algorithms have significant limitations. With that said, let's talk a little bit about some of the considerations we need to have when we're thinking about using GenAI as part of our software development work. The first thing is we have to consider the code quality. GenAI, it is a fantastic technology. It is amazing the impressive results it can create. But it is crucial for us to understand that the generated code might have quality issues. It needs to be properly reviewed, and sometimes we will get code that doesn't compile, doesn't work as expected, doesn't do what we want it to do. Sometimes the algorithm will not be able to capture the overall context of the project. Sometimes it will not be able to fully grasp all of the nuances of complex requirements. So code quality, we shouldn't take it for granted. There's also the problem of dependence. If we become dependent on these types of tools, then we're going to lose some of our skills, which might cause problems down the line. Because again, we have to review what the GenAI algorithm is producing. We have to be on top of that. Of course, there could be licensing issues. This is something that you have to consider with your organization, potentially involving the legal department to ensure that the code produced by these tools is acceptable within your organization. There are also some organization policies that might be a hurdle in the adoption of these tools. For example, there might be policies that will prevent you from using these tools because as you're working, you are sending some data to this tooling. So, hey, is it acceptable to send this? What kind of data are we sending? Is the tool actually receiving some of the code snippets that we have in our IDE at the time? So all of these things must be carefully considered before we start using this. So, in large organizations, these concerns are very relevant. There's another big consideration. Should we even be using GenAI? Again, GenAI is very useful for generating boilerplate code. But, is there a better way for us to deal with this boilerplate code? Keep in mind that as much as GenAI is exciting and cool and, everybody's talking about it, there are a lot of other tools that can also help us deal with some of these problems. You have code generation tools that truly understand the AST, that truly understand the abstract syntax tree of the code you're writing, and can help you with some of the boilerplate. There's also, object-oriented techniques that might help us avoid this boilerplate altogether. Just because GenAI makes it easy to write doesn't mean we should even be writing this code. And this is where our judgment as senior software developers comes into play. You know, should we even be using the tool? Or is there a better way to approach this problem without introducing extra code? Because again, all of the code that is generated by GenAI is going to have to be maintained. We're going to have to think about the unit test. We're going to have to think about documentations, all of those things, which, GenAI is going to make easy or a little bit easier, but we still have to do it. Now, let's talk a little bit about limitations. Because, any tool, doesn't matter how shiny, is going to have a lot of limitations. The biggest limitation is probably that current models have limited creativity and problem solving. GenAI might seem like something straight out of a science fiction movie, but it is limited by the training data that it has. And therefore, it will definitely struggle to have true innovation and true independence to solve complex problems. If you have problems that require out-of-the-box thinking, GenAI might not be able to provide you with that. Because at the end of the day, whatever solution a GenAI tool can give you is going to be heavily reliant on the data that was used to train the model. Another issue is the understanding of the context. As I mentioned before, at least, the most popular tools out there, they have been trained with a predefined code base, and we don't really have control over what code base it's being used. So it might not have all of the context for the problems we're dealing with. And again, I really expect that future models are going to be a lot more context aware. They're going to be a lot more customizable. But nonetheless, keep in mind that the algorithm might not have all of the context that you have. So whatever comes out of the algorithm, it is probably important for us to review and make sure that it fits within the context in which we're working. It is also important to keep in mind that, again, because of the limitations of the tool, it might be unable to handle complex logic on common code bases. GenAI thrives on well-defined inputs and common programming patterns. If your organization is using patterns that are uncommon, if you have very intricate logic, very large systems that have many intertwined parts, or for example, if you're using frameworks or libraries that are not as common, this will present very significant challenges to the GenAI algorithm. So the algorithm might not give you code that is as appropriate within your context. With that said, if we do choose to go ahead and use a GenAI tool, what are some of the best practices that we can use to ensure that, we don't paint ourselves into a corner? Review all of the code. Do not assume that the code that was provided by the GenAI tool is completely free of defects. We have to manually review it. It has to follow, the regular code review patterns, things like that. We want to use it strategically. Again, GenAI provides the most value when it is used for repetitive tasks, for boilerplate code, things like that. Keep in mind that, again, this is fairly new technology and there's going to be continuous improvement. So it is important to stay on top of this to make sure that we get value of the new improvements that are coming down the line, because, again, this is a very hot topic and I'm sure there's going to be lots of improvements in the future. And also make sure that you are leveraging automated testing to reduce some of the risks. Uh, Again, you want to couple good testing with good code to ensure that you have a reliable and maintainable code base. All right. Um, and within the practice of software development, keep in mind that GenAI can also help us for some other tasks that we have. For example, GenAI can help us explain code. If we have code that is very complicated, we can ask GenAI to, hey, explain what this code is doing to me. And, it can give us at least a head start to understand complicated code. It can help us find bugs in the code, together with all of the other tools that we have in our toolbox, automated testing, static analysis, dynamic analysis. GenAI is another tool that can help us find bugs. It can help us translate between languages. If you have a legacy code base that you want to migrate to a modern, easier to maintain, more performant, more reliable language, etc., GenAI can actually help you. There are models that can help you, for example, translate COBOL, which is probably one of the most entrenched legacy languages in the world. It can help you translate COBOL into newer languages. Obviously, all of the limitations that we were talking about, they still apply, but it is a tool that is worth exploring. GenAI, again, it is great for generating content. And one type of content that it can help us generate is documentation. So, developers tend to dislike documentation in general, but GenAI can help us, make that task a little bit less boring. So, let's keep an open mind about all of the ways in which we can leverage GenAI. All right. So with that said, this is a fascinating new field. New developments are unveiled almost weekly. All of the big players are releasing new models, new functionality, new things. But keep in mind that at the end of the day, it is another tool in our toolbox. And we have to be smart. We have to be strategic about how we're going to use this. And this is a pretty short video. I'm not going into as much details as I would like to, because again, the tooling, the technology is changing so fast that I'm sure I'll have to revisit this in a few months, and it's going to be a very different scenario. Now, with that said, in the next video, we're going to be talking about tools and techniques for managing and maintaining legacy code. In this particular video, we talked about, hey, how do we create new code? In the next video, we're going to be talking about how do we manage the code that we inherited that was written 5 years, 10 years, 20 years ago. So thank you for watching. Don't forget to subscribe. You can follow me on X. You can follow me on Mastodon, and check out the website for the book, srdevin24.com. Thank you, everybody, and see you next week.